Hey everyone, we are moving into lesson 1.5, which is presenting experimental data. And as you've probably noticed, we're going through the scientific method as best as we can. So we started asking questions. In the lab, you conducted background information. We're going to work on forming hypotheses. These are pretty simple things, but we talked about experimental design last week, and now we're going to talk about that sort of data, results, findings of the experiment and how to present them, especially in a lab report, which is, in my opinion, the most fun, but the most complicated, especially as we're coming back and trying to be students again in a normal but non-normal way. So if you're not planning on taking notes, not a good idea. You should be taking notes on this because we're going to use it for the rest of the semester and the rest of the school year. And I'm going to expect that you know how to do this. Okay. And if you have any questions, please write them down so we can go over them in class next time. Let's get started. Presenting experimental data. Very, very cool thing about science is that we get to play with data in really diverse ways. But by the end of this lesson, you should know that the importance of collecting data, why we do it. Comprehend that there are multiple forms of data collection. The way that we interpret it or the way that we present it, there are lots of different ways to do that. And then really important, I'm going to go through how to label tables, graphs, and diagrams correctly, especially when you're presenting them in your lab reports. What is data? Data is the account of findings within an experiment. Every time you do an experiment, your hope is to get answers or to get some kind of numbers or to get some kind of result that signifies importance. And that's what data is. That's what's going to give you that result or that answer. As we continue to expand our experimental standards, we should know that data must be presented in an organized manner. There's nothing worse than trying to prove a point and then you have like this jumbled expression of ideas. We want to be professional, we want to be scientists, and we need to be organized when we do that. And then it should be visual and easy to read. I use this word visual. It's really up for interpretation. Visual is anything that's not written down. So anything like a table, like a graph or a diagram is visual, even though there's words in them. Anything other than just writing it in paragraph form is visual. How do we present data? There are really 4 basic ways to do so. The first one is in text, forming tables, building graphs, and attaching or drawing diagrams. So in text, tables, graphs, and diagrams. You're going to do all 4 of these at some point during the year, and it's important that we know how to label them. And of course, this is going to take time. It's going to be trial and error. It's going to feel like a lot of information right now, but I promise we'll work through it. It's going to be great. It's going to be fun. And of course, if you find a better way to do it that's equally as organized, be my guest. This is just my suggestion, and we can go from there. But I love to hear opinions. I love to learn different ways to do things. So in-text data, probably the most basic type. It's presented using sentence structure. You mostly present in-text data using paragraphs. And this can be used for all experiments. All experiments, when you present that data or when you present your findings in an experiment, you can write it down in paragraph form. It should be easy to follow. But is it scientific enough or is it easy to understand? This is the real question. In-text data usually does not include numbers, and it is just a retelling of your results. So if we are doing the experiment with the Skittles, we could say, well, this Skittle had the strongest coating, this Skittle had the weakest coating. But is that the most effective way to do it? Attaching a picture would have been, in my opinion, a more effective way to kind of deliver that information. Most of the time when you read in-text data, it's for a failed experiment. And oftentimes these failed experiments get published or you read about them using this sort of in-text feature of data because it didn't work or because they didn't get enough results to kind of accumulate something to make to make visual data. only use in-text data if a table, graph, or diagram cannot be created. This is the rule. You should never write out your results unless you cannot form a table, graph, or diagram. And we'll talk about what each of these mean and how to use them in just a second. I pulled up a published paper that I wrote, I know, because I am amazing. This is an example of in-text data. This is the results section of one of the lab reports that I wrote while I was doing research. And you can read through it, it's probably not gonna make any sense to you, but as you can see, there are no numbers, there was no way we could make a table, graph, or diagram with what we got. So we sent this to the publishing company, or we sent this to be peer reviewed, hoping that they would consider our failed experiment as something that we could show as part of our research. So again, not super fun, but a great way to kind of get your point across, even if you didn't do as great. Table is probably my favorite thing. Everything I do includes a table. I love the way it looks. I love the way it's structured. Data with tables. Tables are a visual representation of data. Although they have numbers and words, they are visual representations. They can be included, they can be labeled so that it's easy to find, it's easy to see what your results were. And they're used for making comparisons amongst two or more groups. So if you have different groups of people or of factors in your experiment, a table is a great way to kind of organize the different results you got for them. All tables must include a header title, a row of descriptions, units, and a caption. On any lab report that requires a table, I will take off points if you don't have one of these. Tables are called tables, and I'll explain what this means in just a second. This is an example of data with tables. You can see here that I tested one group of students with candy and one group of students without candy. This is the average score that they got on the test between all students. I have a header title and I have a caption. Visual representation of data. This is much easier to read than me writing a paragraph about it. But again, you know, it worked. I had numbers, I was able to put this in a table. And if we look at, you know, this sort of section, it's kind of hard to see it in here. So what I did was I created another table, or I used a table from last year. And in this case, we have the heights of the students in block A, conceptual physics. I have my student names, I have their heights. And you can see here, I have a header title, which goes above the table. This is the first table in the lab report, so it is table 1. Any table that comes after that would then be table 2, and a table after that would be table 3. I have a row of descriptions. Student name is a description, height is a description. This needs to be included in the table before any numbers or any names so that we know what we're looking at. I have units up here. The units are centimeters. The unit can go in the row of the descriptions. That means that all these numbers are in centimeters, and it should be pretty easy to read at that point. You do not need to put centimeters after each number because it's already in the row of description, okay? If you don't put a unit here, you need to put a unit after every number, okay? So that I know as the reader, you are measuring in centimeters, but this is perfectly okay to just put it on top. Same on this side, you could put name, Caleb Bando, name, Francis Foy, or you could just put name up here. Pretty simple. And the last thing, you need a caption, and the caption should be something very specific. It should say everything we need to know about the table in the caption. Table 1 shows the respective heights of students in centimeters in block A of conceptual physics at Mayfield Senior School. Very, very, very descriptive. It is a caption. It is not like a cool Instagram caption, hashtag whatever. It is specific to the table, whereas the header title is just very simple. Heights of students in block A conceptual physics. The caption gives us a little bit more detail, and the detail that we need. Graphs. Graphs are also visual representations of data. They are used for making comparisons over time or within an experiment or within two factors of an experiment. Usually we have like X and Y axes and all that. But I'm going to allow line graphs, pie charts, and bar graphs as part of our curriculum. And again, like tables, there are things that have to go in graphs, and that is a header title, axes titles with units, and captions. And I'll show you when we make graphs how to do this on Google Sheets or Google Docs. It's pretty simple. Really, really important, graphs are called figures. When we label graphs, we need to say, we can't say graph one, we need to say figure one. These are just a couple of just pie charts, bar graphs. I know you guys have seen these before, but what we really want to consider is something that looks like this. And I know you don't understand what this means. Again, I just pulled this from a paper that I wrote because I had it handy. You can see here, I have a header title, which goes on top of the graph, and I have labeled it figure one, which means it is the first graph that I have in my lab report. I have axes titles with units. This is my Y axis. It is energy. We have a unit here, energy. And I have axes titles, which is end-to-end distance, with a unit, which is amperes. Again, don't need to understand what's in the graph, just need to understand how the graph is formulated and labeled. And of course, I also have my caption down here, which goes beneath the graph. You really can't go wrong. Header title, axes units, we need to know what we're looking at. Sometimes it'll be like distance over time, things like that, because we're doing a lot of physics in this class. And again, they're called figures. Caption is a little bit more specific than what's in the header title. And again, this is just how much energy passed through a wave particle atom. We use quantized light when we did this. And I'll tell you more stories about that. But I just want you to understand sort of the labeling and the ability to pass on to the reader like that easier form of breaking down the graph with these three components in there. Even if you didn't know what this graph was saying, by reading the header title, the units, and the caption, you can kind of figure it out. If this wasn't there, it would be almost impossible. And then finally, we're going to move to diagrams. Diagrams are visual representations of data. Diagrams are photos, drawings, and numberless models of data. Super, super important that we include diagrams whenever we can. Anytime you take a photo, that is a diagram. Anytime you draw anything, that is a diagram, and that can go in your lab report as a form of data. Diagrams are very easy to label. They don't need a header, they don't need units, but they do need a caption, and I'll give you an example of this. Diagrams are also called figures. Here is something that was in our lab report as well. You can see this was the 8th figure in our lab report, figure 8, and it is a molecule with some kind of carbon on there. And of course, we have a bunch of nitrogens attached here. And you can see all I had to do was put a caption underneath here, and I presented the data correctly. It makes the reader more engaged. It allows the reader to understand what's going on in this picture. Of course, nobody put captions underneath their photos in the Skittles experiment, but now you know, this is how we do it. This is what expected. This is what is expected, and this is what needs to be done. Okay. If there is a graph and a figure, whichever one goes first, I'm sorry, if there's a graph and a diagram, whichever one goes first is figure 1, even if it's a graph. And then if a diagram comes in after that, it is not figure 1, it is figure 2. So we go in kind of an order between graphs and diagrams. But usually you won't have both, you'll just have one. Little bit of review, present data visually if you can. All tables must include a header, title, row of descriptions, units, and a caption. Super important, and I promise I'm gonna go light the first couple times, but as we get more comfortable with this, this is expected work from you all. And of course, ask me, I will help you. I will do whatever I can to make you more comfortable with this sort of rules of presenting data. And then graphs and diagrams are called figures and must be labeled correctly. So the graph needs a header title, axis titles with units, and a caption. Diagram just needs a caption. But remember that sort of sequential order, we need to label them correctly if they come in that order. Cool. Thank you so much. If you have any questions, please let me know. We're going to practice this next time. Thank you for watching. And this is my bench behind me that is in my garden. See you later.